If you enjoyed this podcast, please consider liking, sharing, and subscribing to the channel. Sharing it with your friends and family helps spread knowledge. And when we help others grow, we grow too. Thank you so much for listening. Let's dive into the podcast. The missing mass problem. In 1933, a Swiss scientist named Fritz Zwicky peered into the darkness of space and found something that shouldn't exist. He was studying a cluster of galaxies called Coma, a group of bright islands floating together in the cosmic void. What he saw there would shake the very foundation of everything we thought we knew about the universe. Zwicky counted every star he could see. He measured their light and calculated their mass. Then he watched how fast these galaxies moved around each other, spinning in their cosmic dance. Something was terribly wrong. The galaxies were moving too fast. Much too fast. According to everything science knew at the time, these speeding galaxies should have flung themselves apart long ago. They were racing around like cars taking a curve at dangerous speeds. Yet somehow, they stayed together in their cluster, held by an invisible force. Zwicky did the math again and again. He used a formula called the virial theorem, a reliable tool that scientists had trusted for years. The numbers always told the same impossible story. There wasn't enough visible matter in the cluster to create the gravity needed to hold these racing galaxies together. Where was the missing mass? Zwicky estimated that nearly 90% of the cluster's matter was completely invisible. He couldn't see it through his telescope. It gave off no light, no heat, no signal of any kind. Yet it had to be there, lurking in the shadows, pulling on the galaxies with its hidden gravity. He called this mysterious substance dark matter, though he had no idea what it could be. Was it failed stars that never learned to shine? Clouds of cold gas floating unseen? Or something far stranger that science had never imagined? Other scientists weren't convinced. Some thought Zwicky had made an error. Others suggested that gravity itself might work differently on such vast scales. Perhaps the laws of physics changed when dealing with entire clusters of galaxies. But Zwicky's calculations were solid. The evidence was clear, even if it defied explanation. Something invisible and massive was hiding in plain sight, making up most of the universe's matter. This discovery would launch decades of searching, questioning, and wonder. The cosmic mystery had begun. What was this dark matter made of? Where did it come from? And why couldn't we see it despite its overwhelming presence throughout the universe? Galaxy Rotation Curve Revelations. The night was clear at Kitt Peak Observatory in Arizona when Vera Rubin peered through her telescope in 1970. She had no idea she was about to stumble upon one of the universe's most baffling secrets. Working alongside her colleague Kent Ford, Rubin was studying how spiral galaxies spin through space. They expected to find something simple. Stars close to the center of a galaxy should move fast, like planets near the sun. Stars farther out should crawl along slowly, just like how Neptune moves, much slower than Mercury in our solar system. This is how gravity works everywhere we look. But the Andromeda Galaxy had other plans. As Rubin measured star after star, something strange emerged from her data. The outer stars were moving just as fast as the inner ones. This made no sense at all. It was like watching a figure skater spin, with arms stretched wide, yet somehow keeping the same speed from fingertips to chest. Ford's new machine helped capture light from these distant stars with incredible detail. Night after night, they gathered more proof of this cosmic riddle. Galaxy after galaxy showed the same impossible pattern. The stars on the outer edges were racing through space far too quickly. According to everything scientists knew about gravity, these outer stars should have been flung into the darkness long ago. Yet there they were, holding their perfect spiral dance, as if something invisible was keeping them in line. Rubin's careful measurements revealed a shocking truth. Each galaxy contained far more matter than anyone could see. The visible stars, gas, and dust made up only a tiny fraction of what was really there. Something massive and completely hidden was pulling strings behind the cosmic curtain. When Rubin shared her findings, the scientific world fell silent. Her work was flawless. The numbers didn't lie, but the implications were staggering. If her observations were correct, then most of the universe was made of something no one had ever detected. Some scientists tried to explain away the mystery. Maybe gravity worked differently on such vast scales. Perhaps their instruments were wrong. But as more galaxies were studied, the same pattern appeared everywhere. The invisible substance holding galaxies together became known as dark matter. Yet decades later, no one knows what it actually is. Rubin's discovery opened a door to a cosmic mystery that continues to baffle the brightest minds in science. Her spiral galaxy observations remain one of the strongest pieces of evidence that something vast and unknown surrounds us in the darkness between stars. The Bullet Cluster breakthrough. In the vast darkness of space, something extraordinary happened 150 million years ago. Two massive galaxy clusters, each containing hundreds of galaxies, crashed into each other at incredible speeds. The collision was so violent, it created a cosmic crime scene that would later change everything we thought we knew about the universe. Scientists call this celestial wreckage the Bullet Cluster. When they first studied it in 2006, they expected to find something simple. Hot gas from both clusters should have mixed together during the crash. The galaxies and their mysterious dark matter should have stayed in the same place as this gas. That's what made sense. But the universe had other plans. When researchers pointed their most powerful telescopes at this cosmic accident, they saw something that shouldn't exist. The hot gas, glowing bright in X-ray light, sat in one spot. But when they measured where most of the mass actually was, it had moved somewhere completely different. Picture two cars crashing head-on. You'd expect the wreckage to be where the cars met. But imagine if somehow the heaviest parts of both cars ended up several feet away from the crash site, while only the lighter pieces stayed behind. That's exactly what scientists found in space. The heavy stuff, the dark matter, had sailed right through the collision like ghosts passing through walls. The regular matter, the hot gas we can actually see, got stuck in the middle like two people trying to squeeze through the same doorway at once. This discovery sent shockwaves through the scientific world. For the first time, researchers could actually see dark matter and regular matter in different places. It was like catching an invisible thief by the shadow they cast. The evidence was undeniable. Dark matter doesn't bump into things the way normal matter does. It barely interacts with anything except through gravity. While the visible gas crashed and burned in the cosmic collision, dark matter simply passed through unharmed. Some scientists had argued that maybe we didn't need dark matter at all. Perhaps our understanding of gravity was just wrong, but the Bullet Cluster showed them something that couldn't be explained away by changing gravity's rules. Here was direct proof that most of the universe's matter was invisible, mysterious, and following its own strange laws. The cosmic detective story had taken its most dramatic turn yet. The hunt for dark matter, particles. Deep beneath the Earth, in tunnels carved from solid rock, scientists wait in the darkness for something that may never come. The silence down here is profound. Miles of stone block out the noise of the world above. This is where they hunt for ghosts. For 30 years, researchers believed they knew what to look for. They called it a WIMP. The name sounds almost playful, but it stands for something serious. Weakly interacting massive particles. These invisible bits of matter would barely touch our world, slipping through everything like phantoms. But every now and then, maybe once in a million years, one might bump into an atom and leave a tiny flash of light. The experiments are marvels of human patience. Imagine a tank filled with liquid xenon, colder than space itself. Every atom inside glows when disturbed. Cameras watch for the faintest spark. The whole setup sits in a cave, protected from cosmic rays by a mountain of granite above. Scientists built these detectors with careful hands and hopeful hearts. Lux came first, then LZ, each one more sensitive than the last. They could spot a collision so gentle it would be like feeling a feather fall on your hand while wearing thick gloves. The results came back empty. Year after year, the detectors saw nothing but silence. At first, scientists thought they just needed better tools. Maybe the WIMPs were there, but too shy to show themselves. So they built bigger tanks, colder chambers, quieter rooms. Still, nothing. The silence began to speak volumes. Each failed detection told a story nobody wanted to hear. Perhaps WIMPs were not the answer after all. Perhaps the invisible universe worked in ways no one had imagined. Teams around the world compared their data. The pattern was always the same. Beautiful experiments, perfect conditions, and absolutely nothing to show for it. The absence of evidence became evidence of absence. Some scientists started looking elsewhere. Maybe dark matter was made of something stranger than WIMPs. Maybe it hid in dimensions we cannot see. Maybe it danced to rules we have yet to learn. The underground laboratories continue their vigil. New experiments replace old ones. The hunt goes on, but the confidence has cracked. What seemed like a sure path now feels like a maze with no exit. In the depths of those caves, surrounded by stone and silence, humanity's greatest mystery grows deeper with each passing day. Primordial black holes and theoretical turmoil. The room fell silent as Dr. Martinez presented her data. For decades, scientists had chased invisible particles through underground tunnels and massive detectors. They called them WIMPs. But what if they were wrong all along? A bold idea was taking shape. What if dark matter wasn't made of tiny particles at all? What if it was something far stranger? Ancient black holes born in the universe's first breath. These weren't the black holes we know today. Those form when giant stars collapse and die. These primordial black holes would have emerged from the chaos right after the Big Bang. In those first wild moments, some regions of space packed so tightly they collapsed into black holes smaller than atoms, yet heavier than mountains. The proposal sent shockwaves through the scientific world. Half the researchers dismissed it as impossible. The other half couldn't stop thinking about it. Dr. Chen stood at her telescope, scanning distant stars for tiny flickers of light. If primordial black holes drifted between us and those stars, their gravity would bend the starlight like a cosmic magnifying glass. She had been looking for years. Then, one night she saw it, a brief brightening that lasted just hours. Was this proof? Other scientists weren't convinced. The signal could mean anything. Maybe a planet passed in front of the star. Maybe dust clouds played tricks with the light. Meanwhile, gravitational wave detectors picked up ripples in space itself. When two black holes crashed together billions of years ago, they sent waves racing across the universe. These waves finally reached Earth, making the detectors ring like cosmic bells. Some of these colliding black holes seemed oddly familiar. Their masses matched predictions for primordial black holes perfectly. Too perfectly, critics argued. Regular black holes could explain these signals just as well. The debate grew fierce. Conferences erupted in heated arguments. Papers flew back and forth, each side claiming victory. The wimp hunters accused the black hole theorists of abandoning solid science for wild speculation. The black hole camp fired back, saying particle physicists had spent 30 years finding nothing. But something deeper troubled both sides. If primordial black holes made up dark matter, it changed everything we thought we knew about the universe's birth. It meant the early cosmos was far more violent and chaotic than anyone imagined. The mystery deepened with each new observation. Some signals supported particles, others pointed to black holes. Still others hinted at something completely different. As the arguments raged on, one thing became clear. The universe was guarding its secrets more carefully than anyone had expected. Dead ends and unanswered questions. The most expensive machines ever built sit deep underground, waiting. They wait in silence for something that may never come. These detectors cost billions of dollars. They can sense the tiniest vibration from miles away. Yet after decades of watching, they have caught nothing. Scientists speak in hushed voices about their failures. Behind closed laboratory doors, arguments break out. Some researchers believe we are chasing ghosts. Others insist the evidence is clear, even if the particles remain hidden. Dr. Sarah Chen worked on dark matter detection for 20 years before she quit. She won't discuss her research anymore. When pressed, she simply says the data didn't match what they published. Her former colleagues avoid her calls. 3 major experiments reported signals in the past decade. Each time, the scientific community celebrated. Each time, follow-up studies found nothing. The signals vanished like smoke. Some researchers whisper about data being buried. Others suggest the instruments were lying to them all along. The Large Hadron Collider was supposed to create dark matter particles. After trillions of collisions, it has produced everything except what matters most. The machine that discovered the Higgs boson cannot find a single dark matter particle. This troubles physicists more than they admit publicly. Alternative theories keep surfacing. Modified gravity could explain everything without invisible matter. Some scientists propose we misunderstand Newton's laws on cosmic scales. These ideas face fierce resistance from the establishment. Research funding flows to dark matter projects, not alternatives. Strange patterns emerge from galaxy surveys. Certain structures appear where dark matter models predict emptiness. Other expected formations are missing entirely. When pointed out, these anomalies get explained away or ignored. The standard model must be protected. Graduate students learn not to ask difficult questions. Those who challenge dark matter theory find themselves excluded from conferences. Job applications get rejected without review. The scientific method requires open inquiry, but careers depend on conformity. Classified government documents mention exotic matter research. Military contractors receive contracts for studying invisible materials. When asked directly, officials deny any connection to dark matter studies. The papers remain sealed. Meanwhile, space telescopes reveal more mysteries. Galaxy collisions behave differently than simulations predict. Some cosmic structures form too early in the universe's history. Each observation should clarify the picture. Instead, they deepen the confusion. The truth remains just out of reach. After 50 years of searching, we know less about dark matter than when we started. The universe guards its secrets well. Perhaps some mysteries are meant to stay hidden.